Since we've gone over multiple forms of how to solve equations, now we're going to add in another aspect of it, and we're going to include absolute value. It's important to kind of go over this page because it helps you to understand when you can have negatives and when you cannot. So here it says this symbol, we know the two straight lines denote absolute value of x, which is the number without its sign. So whatever's inside of the absolute value can be negative. It's just the answer that cannot be negative. So right here, this is okay. What's inside can be negative. It's just the answer cannot be negative. Okay, so I couldn't say the absolute value of 3 is negative 3. It's this part that cannot be negative. So here it says, if x is greater than or equal to 0, then the absolute value of x could be x. And if x is less than the 0, then the absolute value of x is negative x. So geometrically, the absolute value of x is the distance of x from 0. Both 3 and negative 3 are a distance of 3 units. Remember before we talked about the fact that distance is always positive. It says right here, distance in mathematics is never negative. So absolute value equations. If you have the absolute value of a, we're looking for what could we put in here that has a distance away from our 0 of 5. So when you're looking at what this could be, it could have two options. I could say that the absolute value of 5 is 5, but I could also say that the absolute value of negative 5 is 5. So I take what's on the inside and I set it equal to the positive and the negative solution. It doesn't mean that the distance is negative, it just means what's inside of the absolute value is negative. We call what's inside of the absolute value, this right here, is called the argument. The argument is what's inside of the absolute value symbols, and that can be positive or negative. So if we look here, it says solve for x, okay? What we're doing is we're saying, okay, I'm going to kind of put it over here. What's inside here has a distance from 0 of 8. Now, keep in mind, whatever's in here could actually equal 8, or it could equal negative 8, because when you get to that final part, the absolute value of 8 is 8, or the absolute value of negative 8 is also 8. So what we want to do is we want to take what's inside here. I'm going to do this. I'm going to set x minus 2, not the absolute value of x, just what's inside. X minus 2 is going to be equivalent to 8, and x minus 2 is going to be equivalent to negative 8. Those are the two things that we're setting up. So our argument could be one of these two things. So if it's x minus 2 equals 8, I could add 2 to each side, and I could say x equals 10. If this is the case, I can add 2, and I can say x equals negative 6. Notice they aren't just opposites of each other. And what you want to get in the habit of doing is going back to the original and plugging it in. So I'm going to take 10, I'm going to say the absolute value of 10 minus 2 is 8, and I'm going to do the other one, the absolute value of negative 6 minus 2 is 8. And I'm going to check. 10 minus 2 is 8, and the absolute value of 8 is 8. So this one works. When I do the next one, I get the absolute value of negative 8 is 8, and the absolute value of negative 8 is 8. So we know that it checks out. So these are our two solutions right here. Most important thing to keep in mind is the fact that they are not just opposites of each other. It's not just 10 and negative 10. It's 10 and negative 6. So here we're going to just kind of go back to the basics. So absolute value of 6. How far away is 6 on the number line from 0? 6 units away. How far away is negative 5? It's 5 units away from 0. The next one we have to do some calculations. So 2 minus 7, or 2 plus negative 7, is negative 5. And the absolute value of negative 5 is 5. Remember, what's inside can be negative, but our answer is never negative. Next one, 11 minus 8 is 3. Absolute value of 3 is 3. So this is kind of what we did in the very beginning of the year. That's why they're called level 1 type of questions. Now we're going to get to another one. What numbers could we plug in for x that have a distance away from 0 of 9 units. In this case, x could be 9, or x could be negative 9. So checking our work, is the absolute value of 9 9? Yes. Is the absolute value of negative 9 9? Yes. So those work out. These basic ones don't require anything, and you'll notice that they are opposites. Over here, absolute value x could be 11, or it could be negative 11. When you start out on these level 2 type of questions, you're going to find that they are opposites, but when you get into more challenging questions, they are not going to be opposites. So our answers here are 11 or negative 11. Next one. What number could we plug in for x that has a distance of negative 4? So it's kind of a trick. You would put no solution. Remember, our answer can never be negative because this would represent a distance that's negative, and we can never have that, so that won't ever happen. We'll say no solution. There's nothing we could plug in there. Now here, we're going to get to problems that require more than one step. Our goal, I'm going to put this down here, goal is to get the absolute value of x by itself. So just like when we were solving our one-step, two-step, multi-step equations, we want to get x by itself, in this case absolute value of x. So in order to do that over here, I see that it's connected to a 3 by multiplication. To undo that, I'm going to divide by 3, and I'm going to get the absolute value of x equals 4. So then we have to decide, what numbers could I plug in for x that have a distance away from 0 of 4? I could say x equals 4, or x equals negative 4. Those are my two solutions. Now here, when we have divided by 5, to undo that, we're going to multiply by 5. Here, we're going to be left with the absolute value of x equaling 15. So I could say x equals positive 15, or x equals negative 15. Again, we're still stuck on the fact that they're opposites. Our goal on this next one, to get absolute value of x by itself, in order to do that, we're going to have to add 5 to each side, and we'll be left with the absolute value of x equaling 8. So in this case, x could equal 8, or x could equal negative 8. Now we've got some multi-step equations, and it's important, again, to get the absolute value of x by itself. Okay, so here we're first going to have to multiply by 4, which leaves us with the absolute value of x plus 2 equaling 12. Now our absolute value is not by itself yet, so we still have to subtract 2 from each side, which is going to leave us with the absolute value of x equaling 10. So x could equal 10, or x could equal negative 10. Again, still opposites. Here we are going to subtract 6 from each side. 3 minus 6 is going to give us negative 3. We're asking ourselves, what number could we plug in here that has a distance of negative 3? In this case, it's going to be no solution. Over here, get that absolute value of x by itself. We're first going to add 9. So we get 5 times the absolute value of x equals 15. Divide by 5. And absolute value of x equals 3. So what numbers could we plug in that have a distance of 3? That would be x could equal 3, or x could equal negative 3. Now this is where we have to really pay attention. So you want to make sure you're going over this several times. Our goal is to get whatever's in here, whatever we're taking the absolute value of, by itself. And now we are going to set our argument. Remember, our argument is whatever's in here. So our argument is what's inside. And we're going to set that equal because, remember, looking at number 14, whatever's in here could equal 4. So that means whatever I just underlined, this x plus 5, could equal 4, or our x plus 5 could equal negative 4, because at the end of the day, the absolute value of 4 is 4, absolute value of negative 4 is 4. So we've got to figure out what those solutions are going to be. If I subtract 5 from each side, I could say x could equal negative 1. There's one solution. Or, now I subtract, and I get x equals negative 9. So I have two solutions. I'm going to check them. If I had negative 1 plus 5 in my absolute value, does that equal 4? That'd be the absolute value of 4, which is 4. That one checks out. Now I'm going to try negative 9. Negative 9 plus 5, does that equal 4? That gives me the absolute value of negative 4, which is 4, and it checks out. So I took my argument, what was inside, just that, no absolute value symbols, nothing of that sort, just what's in there, and I set it equal to the positive and to the negative solution. So I'm going to do the same thing on this next one. I'm going to choose different colors so that we don't mess it up. So I'm going to take what's inside, 2x plus 9, and I'm going to say that that can equal 21, or I could take my 2x plus 9 and set that equal to negative 21. So I'm going to subtract 9 over here. And I'm going to get 2x equals 12, divide by 2, and x could equal 6. There's one answer. Or I'm going to subtract 9. I'm going to say 2x could equal negative 20, divide by 2, and I'm saying x could equal negative 10. I'm going to check my solution. So I could have 2 times 6 plus 9, take the absolute value, so I could have 12 plus 9, absolute value, which is the absolute value of 21, which is 21. It works. Or I could say negative 10. 2 times negative 10 plus 9 equals 21. So I could say negative 20 . Oh, I did my math wrong. Let's reverse a little bit. I gotta erase some stuff. Okay, I don't know why I said that. This should be negative 30. Negative 30. Come on, Miss Sullivan. And this would be negative 15. Sorry. I can really do math, I promise you. So here we've got 2 times negative 15, which is negative 30, plus 9, which is going to be the absolute value of negative 21, which gives us 21. So it does check out. And you'll notice that because I did this check, I was able to see that I made a mistake. And that's why it's so important for you to check your answers, because you can pick up on mistakes like that. Please note that these are not opposites. They're two totally different solutions. Same with these two. So please don't just find one solution and then assume that the other one is going to be the opposite of that. Okay, this one, again, we are going to set our argument. Okay, remember, the argument is just what's inside, so no absolute values. 1 minus x, I'm going to set equal to 7, and 1 minus x, I'm going to set equal to negative 7. All right, so I'm going to subtract 1 from each side, and I'm going to be left with negative x equals 6. I'm going to divide by negative 1, which tells me x equals negative 6. There's one solution. Subtract 1. So negative x equals negative 8. Divide by negative 1. And x equals 8. Now I'm going to do my check. Does the absolute value of 1 minus negative 6 equal 7? And does the absolute value of 1 minus 8 equal 7? Does the absolute value of 7 equal 7? Yes. Does the absolute value of negative 7 equal 7? Yes. So we see that those two did work themselves out. Next one, I'm going to set my argument equal to positive 10, and I'm going to set my argument equal to negative 10. So I'm going to subtract 8. I'm going to get 3x equals 2. Divide by 3. One option is x equals 2/3. My next option, subtract 8. 3x equals negative 18. Divide by 3. and x equals negative 6. There's my other option. I'm going to check to see that they work. So absolute value of 3 times 2/3 plus 8, does that equal 10? And absolute value of 3 times negative 6 plus 8, does that equal 10? So 3 times 2/3 is going to be 6/3 plus 8, which is going to be 2 plus 8, which is the absolute value of 10, which does equal 10. So that one works. This one's going to be negative 18 plus 8. Does that equal 10? Absolute value of negative 10. It does equal 10, so it checks out. Notice I'm setting my argument, just what's inside, equal to the positive and negative solution. The next one. Our goal is to get the argument by itself. Notice there's a 3 attached on the outside, so we have to divide by 3 in order to get that argument by itself. So the argument here is the absolute value of negative 9n. When we do the division, we get equals 27. So now I'm going to set negative 9n equal to 27. That's the argument, but I'm also going to set negative 9n equal to negative 27. When I divide by negative 9, I get n equals negative 3. There's one answer. When I divide by negative 9, I get n equals positive 3. So when I check, I'm going to check my work. Say 3 times the absolute value of negative 9 times 3. It's 3 times the absolute value of negative 27, which is 3 times 27, which is 81. That one works. If I do absolute value, 3 times the absolute value of negative 9 times negative 3 is 3 times 27, which is 3 times 27, which is 81. It also works. So again, our goal is just to get this argument by itself. Right now there's a 3 on the outside that's not in the argument, so that's when we have to do some rearranging. The next one, our argument, which is right here, is not by itself. To get it by itself, we have to add 10 to each side. So then we're left with our argument, absolute value of x divided by 2, equaling 2. So now we set what's inside. X divided by 2 can equal 2, or x divided by 2 could equal negative 2. We're setting this argument equal to the positive and negative. So multiply by 2, x equals 4, or multiply by 2, x equals negative 4. So in this case, these are our two solutions. Now, this is a very, very hard lesson. It gets very complicated. Please email me, Sullivan719 at Yahoo, if you have any questions.